Hey everyone, welcome to our next video. This is going to start test 3 material. So let me head over to our notes. So our first section that we'll be doing is 5.1, and this is law of sines. So the point of 5.1 and then also 5.2 is going to be how do we solve triangles that do not have a right angle. So if a triangle does not have a right angle, then we can't use Pythagorean theorem. We can't use like our normal relationships of sine is opposite over hypotenuse. We can't use any of that because there is no hypotenuse. If there's no right angle, there's no hypotenuse. So you can't use any of that stuff. So this type of triangle we're going to be working with is called an oblique triangle. So let me write this out for us. Any triangle without a right angle is called an oblique triangle. And so it's good to remember here that we cannot use Pythagorean theorem. So a squared plus b squared equals c squared will no longer work. And then also the relationships of sine, cosine, and tangent. None of those are working. I also want to mention that when you set up these triangles, it doesn't really matter where you put your angles and your sides. However, it does matter like what is across from what. So if you have like a angle A, you want that to be across from side A. Excuse me. So usually your angles will be capital letters or Greek letters. So we could either call this capital A or we could call it alpha. And then your sides will be your lowercase letters. And so you should always have A across from A. We'll have B across from B, so I'll put B over here. B could also be beta, and it should be across from side B. And then lastly, we can have a side C. In Greek letters, we would call this gamma, and it should be across from side C. So again, you do not have to you don't have to put A right here. You know, you could have put it over here if you wanted to. It just matters that you have the correct angle and side relationship. Now there are some different ways that we can classify triangles based on what we are given. So we will be given at least 3 pieces of information. So of 3 pieces of information about the triangle. So one option is that we are given an angle, a side, and then an angle. And it doesn't have to be right here. Like I could have drawn it like this, angle, side, angle. It's just that we're being given an angle, a side, and then an angle like when we draw it out. So however you want to draw it is fine. As long as they're adjacent, they're right next to each other. So this is the angle, side, angle case. Another case that we can be given, excuse me, is the angle side case. Angle side. Another one we can be given is a side, and then an angle. This is actually a special case. It's called the ambiguous case. And I'll talk about that a little bit later. Let me put it in like parentheses. So these are three options. These are not the only options. However, these are the only options that we will see in 5.1. So all of these, we would use law of sines to be able to solve it. Now, there are two other cases, and I'll bring them up for you. Your other two cases that we can see is side, or side, angle, side. These we'll talk about in 5.2 because we have to use what's called law of cosines for them. Okay. So in our section right now, we're just going to be dealing with those three like upper cases, the ones at the top. And then in 5.2, we'll deal with the others. So let me go ahead and write what the law of sines states. So it says for any triangle. That's actually a pretty big statement there, is to say any triangle. What that means is that it doesn't matter what the angles are, it doesn't matter what the sides are. Law of sines will work. Technically, you could even use law of sines on like a right triangle. Like even if you could use Pythagorean theorem or something, you could use law of sines if you wanted to. It'll still work. It just would probably be a little bit harder. So here is the law of sines. It says the ratio of sine of angle A divided by A is equal to the ratio of sine B over B, which is equal to the ratio of sine C over C. And so remember, those capital letters are the angles, and then the lowercase are the sides. You could also see this upside down. So you could have like the angles at the top if you wanted. I'm sorry, the angles like at the bottom if you wanted to. Sometimes maybe that could be helpful with like the algebra, because we are going to have to do some algebra. But it's totally up to you. I don't really know why. I guess I usually use the one with the angles at the top and then the sides at the bottom. But that's just me. You can do it however you feel comfortable. But either one works. The other important thing to know is that we will only use two of these ratios at a time. So for instance, maybe we'll use A and B to help us out. Or maybe we'll use B and C to help us out. Or maybe we'll use A and C to help us out. So we're only going to use like two of these fractions at a time, like one across from the other. So it's not like we're going to use like all three of them at once or something. So I think let's go ahead and just start an example. So example one, I'm going to say given beta is equal to 34 degrees, gamma is equal to 64 degrees, and side A is equal to 5.3. Solve the triangle. This is something I kind of forgot to mention. You're given three pieces of information. We're going to be looking like for all the other pieces of information. You will need a calculator for this section. So for test 3, you are going to need a calculator. Please make sure that you have an approved calculator. If you come with an unapproved calculator, I just can't let you use it, even though like you do need one for the test. So please keep that in mind. There's really no way for me to make this section possible like with no calculator. So gotta use one. So the first thing that I would recommend is to draw out your situation. So I always like to just draw out my triangle first. And we can put the beta and we can put the gamma wherever we want. If it stresses you out to see it in the Greek letters, you could always change it to the capital letters if you want. Remember, B is with beta and then gamma is with C. So whatever you prefer. And so we can place these wherever we want. It does not matter. So for this one, I don't know, let me put beta over here. So this is 34 degrees. I'll put gamma over here. I'll put it at the top. So 64 degrees. And then so my alpha or my A would be here. My side A needs to be across from that. So my A is 5.3. My side C is across from gamma, and then my side B is across from beta. And so again, you could have ordered this however you want to. Just as long as you have beta across from B, gamma across from C, alpha across from A. So now we need to think about where, like, what can we find? I would say for this one, there's actually only one option. The easiest thing to find right now is going to be alpha. And I'm just pausing so that maybe you can think about it a little bit. So we're going to find alpha. So all triangles need to add up to 180. So if I do 180 minus 64 minus 34, I will get angle alpha, which is 82. So I found that. Now the reason that I needed to go find alpha, to be able to use the law of sines, you need what I like to call a fully developed ratio, meaning you either need A across from A, you need B across from B, you need C across from C. So with our original information, we had gamma, but we didn't have C. So we didn't have a fully developed ratio there. We had beta. Sorry, I didn't mean to have the eraser on right there. We had beta, but we didn't have B. So no fully developed ratio there. And then we had A, but we didn't have alpha. However, it was pretty easy to go get alpha. So before you can use the law of sines, you need a fully developed ratio. I also usually recommend that if you're being given two angles, your easiest thing is going to be to go find that third angle. Now that we have a fully developed ratio, so now that we have alpha across from A, we can go find we can go find B or we can find C. It doesn't matter. So I'm going to go ahead and find B next. So to do that, if I'm looking at my law of sines, I know all the stuff that involves A. So I definitely want to use that. So I have sine alpha over A. And then since I'm looking for B, I want the stuff with B. So sine beta over B. Now we can go ahead and plug everything that we have in. So I get sine 82 degrees over 5.3 is equal to sine 34 degrees over side B. And so we're going to need to do a little bit of algebra here. You may know this as cross multiplying, but what we're going to do is we're going to multiply each one by the other's denominator. So I'm just multiplying both sides by the denominators. Or you can think of this as cross multiplying, whatever you prefer. So what I end up with is B sine 82 degrees is equal to 5.3 times sine 34 degrees. Then I can divide both sides by sine 82. So I get B is equal to 5.3 times sine 34 degrees divided by sine 82 degrees. And we can go ahead and plug this into a calculator. Let me go ahead and do that really quick. I get 2.99 for B. So I'm going to go ahead and box that in. And so if you had tried this before, like we found alpha, you would have had too many unknowns. Like you wouldn't be able to get anywhere. That's why we need a fully developed ratio. So like we need one of these whole like ratios here. Either we have all of A, we have all of B, or we have all of C. We need one of those options to be able to use law of sines. So then for my last step, I need to find C. So I'm actually going to do the same thing that I did before, but now I'm going to use the A stuff, and then I'm going to use C. So instead of B here, I'm using C. That way I can find C. Plug everything in, so I get sine 82 degrees over 5.3 is equal to sine 64 degrees over C. I'll cross multiply here, so that would give me C times sine 82 degrees is equal to 5.3 times sine 64. I'll divide by sine 82, so I get C is equal to 5.3 sine 64 degrees divided by sine 82 degrees. And let's see the value I get for this. I got 4.81. Something else I'd like to mention is to find C, we could have used B and C together. We could have. The issue with that is that B is a rounded value, so it may give us like a rounding error if we were to use that. So I always recommend try to use the information that is given over any information that you found. You always want to use what's given because it's probably going to be like nicer values, so you won't get as much like rounding errors. And so for this one, I didn't even talk about the case, but this was the angle side angle case. I'm going to move on to another example. So example 2 says given B is equal to 121 degrees, C is equal to 16 degrees, and then B is equal to 4.2. Solve the triangle. And so again, when it says solve the triangle, it means we're looking for all the missing information. So first I'm going to draw it out. These do not have to be drawn to scale by any means. I could put B here if I wanted to. I will say that I do like to put them where they kind of look like they would go if I can. So I'm going to put B up here at the top. But I don't have to. Like that's just personal preference. So that means that side B is going to be across from that. And they do tell me that side B is 4.2. This is great. Having that fully developed ratio right from the start is amazing. C, let's put it over here, 16 degrees. And so I'm going to need to find side C, I need to find angle A, and I need to find side A. Now we actually have some options here. And this is the angle side case. So we're being given an angle, and then a side. So we actually have options here. We do have two angles, so we could just go find that third angle right away. That is probably what I would do. But also we do have a fully developed ratio. We have B across from B. So we could actually go get C right now because we would have angle B, we'd have side B, and we'd have angle C, so we could find side C. So we could go do that right in the beginning, but it's totally up to you. I mean, you have some options about what you can do first. My personal preference, if ever I can find like an angle right away, I usually do that. So to find A, I would do 180 minus 121 minus 16, and that gives me 43 degrees. So that is my angle A. And so since angle A is now 43 degrees, we have options. So either we can use the fully developed ratio of B to go find C, or we can go find A. So we can go get either one at this point. Totally up to you which one you would want to go get first. I'm going to go get C first just because. So to find C, I have the fully developed ratio of B, so I want to use that. And then since I'm looking for C, I'm going to use the ratio of C. I plug everything in. And then I'll solve for C. So first thing I do is I cross multiply. So I get C times sine 121 is equal to 4.2 times sine of 16. So I'm just multiplying by those denominators. Divide by this sine 121, so I get C is equal to 4.2 times sine 16 divided by sine 121. I use the little squiggly lines for like rounded values because it is just an approximation. I'm going to go plug this into my calculator. I recommend you do the same to try to make sure you can get these values, but it would be 1.35. At this point in the video, I would recommend maybe pausing and try to go get side A by yourself. But of course, I'll do it. So I'm going to find side A. So to do that, I still want to use the information that I was given. So I still want to use B, and then I'm going to use the A stuff. Plugging everything in. So I get sine 121 over 4.2 is equal to sine 43 over A. Solve this, so I get A times sine 121 is equal to 4.2 times sine 43 divide by sine 121. And let me go plug this in. I get 3.34. So that was the angle side case. And so I just want to mention again, you could have done these two steps interchangeably as your first step. And then once you got angle A, technically we could have done either one of these steps first, like finding side A or finding side C. So it's just it's up to you, you know. Sometimes you do have some options, sometimes you don't. Like example 1, we really only had the one option of finding that angle. We couldn't get anywhere because we didn't have a fully developed ratio. So that's why we like had to get that ratio first to be able to do anything else. And sometimes, you know, it's just like that. Or sometimes you have options. The last case that we're going to talk about in this section is the ambiguous case. So side-side angle is called the ambiguous case because there are multiple possibilities. So with this case, let's say I put A here, B here, C here, A, B, and C. The thing that can happen with this one is one, it's possible that with the information you are given, so let's say you're given, um, I want to make sure I write this correctly. Let's do this side. Let's say you're given this side, and then let's say you're given angle C. The issue here is it's possible to have multiple things happen. Your first possibility is that there is no triangle possible. So it's possible that with the information they give you, you actually can't fit another angle in or another side. Like you can't make it work. So one possibility is that there's going to be no triangle possible. Your next possibility is that there's one triangle possible. And that would be potentially the triangle that I have drawn right now. It's also possible sometimes that there are two triangles that are possible. What happens there is that sometimes what can happen is maybe this side C isn't right there. Maybe it's actually right here. And what that would do is it would change my angle B, it would change my angle A, and it would change my side B. So that's what's happening. Is it's just possible that maybe you could have two triangles be possible, whether maybe your side is on the outside like that, or maybe it's cutting through to the inside. So let me go show you a picture that is a little bit better to look at than what I drew. So here's the idea. So if you look at this, I like this one because it shows like the bold, like side A, side B, angle A. So that's the information that they were given. But then the issue is that the grayed out information could change depending on where that side is supposed to lie. So this is kind of what we're looking at. We're just looking at this weird case that maybe there is no triangle possible. Maybe there is a triangle possible, but there's just one, like it's just one option. Or maybe two options could fit. So it just depends. And I'll show you how to work with any of them. This is kind of what happens with the option that it doesn't fit for the no triangle. Excuse me. So I want to show you something else as well. If we look through these, oh yeah, look right here. This one says one triangle exists, and it talks about the height. Like it's saying, oh, if side A is actually bigger than the height, and side A is bigger than B, then you have this situation. My issue with that is that it's not always going to be side A. Like that's not always going to be the side that they're talking about. So I really do not like that explanation at all. But of course, if you go look, and they have this one as well, where this one right here, they're talking about like the height doing a certain thing, and that's how you figure it out. Okay, here's the thing. What I want to show you is that on my math lab and stuff, if you look at their explanation, they are going to talk about like height and stuff like that. And oh, if this side is bigger than this side, then this is the option and all that kind of stuff. That is not how I like to teach this section because it feels like there's a lot to remember, and it's honestly not that. It doesn't have to be that way. So please just pay attention to the way that I do it. I genuinely do think that it is easier than the way the homework tries to explain it to you. I mean that so genuinely. The homework is just, I don't think it's very good at explaining this. So let's go ahead and start an example. I'm going to do each of these possibilities. So I'll say solve the triangle using the given information. So we're going to do all three options. So for part A, we'll do given alpha is 41 degrees, A is 3.3, and then B is 5.4. And so I'm just going to draw this triangle out just how we normally did. I don't worry that much about like the shape or anything like that. I just kind of draw it on there. So let's say alpha is 41. Let's put it over here. So it's across from A, which is 3.3. B, I'll put down here. Let's say it's 5.4. And then I'll have gamma or C here. There we go. Again, please remember you don't have to draw your triangle exactly how I do. So pretty much I just kind of draw it on there and then I just start the problem. I don't worry too much about trying to draw it to scale or anything like that. So we don't have very many options of what we can do. We can't go get any, like we can't use the whole like 180 minus thing because we only have one angle. So we can't do that. However, I do see that I have a fully developed ratio here. What that means is that I can jump straight into using law of sines. If you have a fully developed ratio, you can immediately start with using law of sines. So let's go ahead and do that. So if I have B, that means I can go find beta. So that's what I'm going to do. I'm going to find beta. And I'm going to use law of sines to do this. So this might be a little different in the solving steps because we haven't done one yet where we like use law of sines to find an angle. So we're going to do that now. So I have sine of alpha stuff, A stuff, whatever, and sine of B or beta. So I plug it in. And I'm going to go through the steps of solving this. So I'm going to do cross multiplying first. So I get 5.4 sine 41 degrees is equal to 3.3 times sine of beta. Now I'm trying to solve for beta, so I'm going to get sine of beta alone. So that means I'm going to divide by 3.3. So I get 5.3 sine 41 degrees over 3.3 is equal to sine beta. Now I'm going to ask a question here. What are we supposed to use whenever we're trying to find an angle? So this is a little bit from chapter 4, the question that I'm referring to. Whenever you're looking for an angle, there's a certain like function that we switch to. And so sometimes I just had us like figure it out because it was values that lied on the table or the unit circle. But sometimes we had to use sine inverse, or we had to use an inverse function in some way. So for this one, if I want beta and it's inside of sine, I can switch this around to sine inverse. So let me remind you of something on the side here. If you have y equals sine of some angle, I'm just saying alpha because I'm just using an angle, I can switch this to alpha would be equal to sine inverse of the y. So in our case, what we're seeing is this beta is kind of like the alpha that I drew, and then this is kind of like the y. So I'm changing my form. So this is going to be sine inverse of all this stuff will be equal to beta. Now, if you do this, which if you have a calculator with you, I really would recommend doing it right now before I tell you what's going to happen. What's going to happen here is you're going to get an error. This means that there is no beta possible for this setup. So if there's no beta possible, there's no triangle possible. So that would be my answer here. I would just say, sorry, there's no triangle that's possible with this information. It literally cannot make a triangle. So again, right, like if you look at my math lab, they're going to say stuff like, if the height is bigger than this other side, or that happens to be across from this angle. I don't know. It just gets super weird. It's maybe not that hard. I just think it's like if your triangle looks different, like if you're given different values, you may get confused on which values you're supposed to be comparing. So that's why I don't like that method. With this method, you literally just like start the problem, and if you get an error, there's no triangle. And you would get the error immediately. So it's not like you'd get like halfway through the problem and then get an error. It's going to be on your first step. Like there was only one step that we could take. We had to go find angle beta, and then we get an error when we try to do it. So it's fairly quick to find out there is no triangle. So that's the no triangle case. Let's go ahead to our next case. So part B. This one I'm going to say given C is 125, B is 5.7, and then C is 8.6. So I'm going to draw everything in just how I normally do. Let's put C at the top since I happen to draw that angle kind of big. Again, there's really no reason for that. I'm just doing it just because. B, I don't know. Let's put it over here. And then I have A across from A. So I'm being given a side, and then an angle. So that's how I know that I have this weird case. So either I can get no triangle from this, I can get one triangle, or I can get two triangles. Whenever you see that case, that's what you're dealing with. So again, we only have one option that we can use. I have a fully developed ratio of C across from C, and then I have side B, so I can go find angle B. So that's what I'm going to do first. I'm going to find angle B. So to do that, I have sine B across from B, and I have sine C across from C. So I plug everything in. And then I'm going to solve this for B. So let me cross multiply first. So I get 8.6 times sine B is equal to 5.7 times sine 125. Divide by the 8.6. So I get sine B is equal to 5.7 times sine of 125 divided by 8.6. And since I'm looking for an angle, I'm going to use sine inverse. So I get B is equal to sine inverse of all that stuff. And let's go ahead and see what I get. This one, I got 32.88. The fact that I got an angle right there means that this is definitely not a like no triangle case. So either there's one triangle or there's two triangles right now. There has to be at least one because I was able to get my first angle. If I got an error, it would have been a no triangle. But since I got the angle, I'm definitely dealing with like at least one triangle is possible here. So let me go ahead and draw that in. I get 32.88. And now we can look at our situation and figure out what we should do next. And so, of course, I want to pause and, let you think about it a little bit. So what should we go get next? We can't get side A because we need angle A to be able to do it. But I can go get angle A because I have two angles, so I can just find the third one by subtracting from 180. So my next step here, it's getting a little out of order. Let me go ahead and number my steps. So next I'm going to find angle A. I already have two of them, so I'm just going to do 180 minus my 125 and minus my 32.88 to go ahead and get this. So let's see what I get. I get 22.12. So there's my angle A. Now I can go get side A. Now be careful here. We do need to use angle A to get side A. So we're going to have to use a rounded value. But we are still going to use angle C and side C to help us because at least those values aren't rounded. So try to use as little rounded information as possible. So I'm going to go get side A right now. So if I do that, I'm going to do sine A over A is equal to sine C over C. I plug everything in. And I'm going to solve this. I'm going to sorry. I'm going to skip a little bit here. So I get 8.6 times sine 22.12. And then that's divided by sine 125. So I did skip a step of my work there, but I've done it a good amount of times so far. So I feel like maybe I can skip a little bit. Hopefully. All right, so I get 3.95 for this answer. So this was my first triangle. Now I'm going to show you how to check for a second triangle. Because we knew at least one was possible, so we went ahead and just found that one. And now I want to show you how do you check for the second. So I'm going to write you out some steps here, just a little bit. So what happens here is basically what we're going to find is there a second B, is there a second A, and is there a second side A that could work for this? So to find a possible second B, here's what you do. Hold on, let me figure out how I want to write this. So right now, my second B that would be possible, I'm going to write, and I'm going to do 180 minus the first B that I found. And so I'm going in order of like what I found. So you do 180 minus that. So I would do 180 minus 32.88. And let's see what I get here. I get 147.12. So what this is telling me is that this is my B2 right now. So this is my B of my second triangle. all of the other information that you were given is still the same. So, like, we still have the same angle C, we still have the same side C. Now we have to check if maybe there's a second angle A. So we're going to check our A2. So again, I'm going like in the order that I went for the first triangle. To find A2, I'm actually going to do the same thing that I did earlier to find A. So if you look up there at A, I did 180 minus my C, which was 125, minus my B value, but now I'm going to use B2. So if I try to solve for this, I get a negative angle for my A2. So we can ask ourselves, should a triangle have a negative angle? Like, does that make any sense? No. What this means is that there is no second triangle. And you might have been able to figure that out by just seeing B2, because if you look at B2 and C, since they're both obtuse angles, a triangle cannot have two obtuse angles because then you're going to get bigger than 180, so it doesn't make any sense. So you might have been able to notice it at B2, but if not, you can always go to the step of A2, and if you get a negative A2, then there is no second triangle. If we had gotten a positive one, then there would be a second triangle. So again, I'm going to recap what we did to check for the second triangle. On our first triangle, the first thing we found was B. So the first thing I did for my second triangle was find my second B by doing 180 minus B. The reason that you do 180 minus is because if we come back up here for a second to my original problem, like original drawing, what we're saying here is, oh, instead of maybe this being my angle, maybe my angle is here. So these are supposedly, like, as you're counting it out, like as you're measuring it out and stuff, they're supplementary angles. So that's why you do 180 minus. And so then for my A2, since A was my next angle I found, I just subtracted the two angles I had from 180, since all triangles add up to 180. But I found that there actually can't be an A2 because I get a negative value. So for my next problem, I'm going to actually show you what it does look like if you can have a second triangle. So this will be our last one for this video. So this says given B is equal to 56.3, A is equal to 8.3, and then B is equal to 7.6, and we're just solving the triangle. So first, I just draw out my triangle, put everything wherever you want. It really does not matter. I'm going to put A up here, and then side A is 8.3. I'm going to put B right here for no reason whatsoever. I just am. And I'll put C right here. So I always like to um, just kind of start with my first triangle first. So if I look through this, I have a fully developed ratio of B. I have side A, so I can find angle A. So for this one, my first step is to find angle A. So let's see. I have sine A over A is equal to sine B over B. And I'm just going to solve all this out fairly quickly. I cross multiply to solve for sine A. So here I'm going to get sine A is equal to 8.3 times sine 56.3 divided by 7.6. Then I use sine inverse. Oh, still equals here. Of all this stuff. And if you want more steps of the solving, I would definitely look at the earlier examples that we did. I tried to be a little bit more thorough. So let's see what I get for A here. Oh, I typed it in wrong. Let me try that again. I got a value that doesn't make any sense, so that's how I know I definitely typed something in wrong. There we go. 65.31. So that is my angle A. Next, I'll go get my last angle. So in this case, that would be angle C. So to do that, I do 180 minus my B that it gave me minus my A. So 180 minus 56.3 minus 65.31. And I get 58.39. And now I'm kind of a fan of using the like 2 decimal places. You can use 1 if you want. Just try to listen to the homework and do whatever it asks you to do. And then for my last step, the only thing that I'm missing at this point is side C. So let's go and get that. So I'm going to find side C. To do that, I still want to use my fully developed ratio of B. So I'm going to plug everything in and see what I get. I know I'm doing this process fairly quickly. Really, I think you should just pause and do it yourself. Let's see what I get. I get 7.78. Okay, cool. So that was all me just finding the one triangle. So very similar to our last example. So that's why I didn't, I might have not talked very much through it and stuff. But excuse me, my throat is like really dry. But I ran out of one of my water bottles. All right. Now let's go ahead and do my second triangle. So I'm going to do my second triangle now. And so again, for my first new angle, my first angle that I found for the first triangle was A. So right now I'm going to find my A2. So to do that, I do 180 minus A. So I'm going to do 180 minus 65.31, and I get 114.69. So that is now my A2. Now I don't know yet if that's going to create a new triangle or not. To do that, I need to check for if my third angle will fit. So right now, my third angle, which is the second angle I found, was angle C. So I'm going to go check that now. So let me go ahead and color code a little bit. So first I checked for a second A. Now I'm checking for a second C. So to find C2, I'm going to do very similar to what I did to find C. I'm going to do 180 minus B, which is what they gave me, and all that information stays the same, minus A2. So the only thing that's changing is instead of the 65.31, I'm going to put in 114.69. And let's see what we get. This gives me 9.01. Since it's positive, that means I do indeed have a second triangle. So if it had been negative, if that C2 had been negative, we would have said, nope, sorry, no second triangle. But since it's positive, we do have a second triangle. So now I have my A2, I have my C2. Now I need to go get my side C2. So I'm just going to try to get that now. So I'm going to actually do the same process I did to find C, except now I'm using, the new C that I have. I know that might have sounded confusing because it was multiple C's. To go get side C, I'm going to use my new angle C. So my C2, my angle C2. So I'm going to write out again. So I have sine B over B is equal to sine, but now I'm using C2 to get the side C2. This is probably why they try to use Greek letters. So I'm going to plug everything in. Let's see what I get. So sine 56.3. So all the B stuff is the same because it was given to us. I'm going to plug this in and see what I get. So I'm going to solve this out. 7.6 times sine 9.01 divided by sine 56.3. So that was just some algebra there. So for my C2, I get 1.43. Oh, not an angle, sorry. Didn't mean to put a little symbol there. I should have over here though. Here we go. So I'm gonna zoom out a little so you can see the whole thing. So first we found just our first triangle, and then we went and found all the information for our second triangle. And you'll notice that I went in the same order. So first I found A, then C, and then side C. So then for my new triangle, I did A2, capital C2, side C2. So I went like in the same order. Okay, so when it comes to doing your homework, something that they usually do is they actually ask you, like, for the first part of a problem, they'll say, like, for this triangle, is it no triangle, one triangle, or two triangles? Like, they ask that, like, immediately. My recommendation is to just start the problem, just like how we would in, like, for our test, basically. So, what I mean by that is, like, they're going to say, okay, here's a triangle. Is it zero? Is it no triangle, one triangle, or two triangles? Just start the problem. If you get an error, then it was no triangle, and you can plug that in. If you get one triangle, you can just check for the second. If it has a second triangle, then you'll find that. And then just like put in all your answers after. Because I think the issue that some people have with the homework is they think they have to follow it like to the T. Like, oh, if they ask this first, I have to plug this in first. No, just do the whole problem on paper, how you would like on a test, and then just plug it into the homework after to make sure you got it right. So I hope that makes sense. And also just be careful for any like rounding errors or anything like that. They can be picky. Oh, I didn't mention this, so I hope you're still here. Let me go ahead and tell you a way to check all of your answers. This might not always work, but it's one way to kind of help you out. Your smallest angle should be across from your smallest side. Your biggest angle should be across from your biggest side. So after you find all of your information, you can always go and maybe like write it in. So let's look at B for a second. So my angle A, what did I get? 22.12. And then for my A, I got 3.95. So it makes sense that C is across from C. Okay, biggest across from biggest. And then B is my next smallest, and that's across from my next smallest angle. I'm sorry, side. And then A is my smallest angle, and it is across from my smallest side. So that's a way to just kind of check yourself and make sure that you probably did it right. So you can always check that kind of at the end of your problem. Okay, so that's going to be it for this section. If you have questions, of course, just let me know. I'd be happy to set up an appointment with you. And I will see y'all in the next video. Bye bye.